So the next result is 1.64, which is an extension of 1.53. So we have theorem 1.64. Again, A n times n matrix. And then we have the following statements that are equivalent. And A, B, C, D is the same as in 1.53. So the first four statements we have already that they're equivalent. So A is invertible. B, A times x equal to 0 has only the x equal to 0, the trivial solution. So the homogeneous system has only the trivial solution. The reduced row echelon form of A is the identity matrix, again would be the same size. Part D, A is the product of elementary matrices. So this is actually up to here is theorem 1.53. And now comes the extension to, because here we, like I said in the previous section, we only talk about homogeneous. Now, what are the implications for non-homogeneous? So if the right-hand side is an arbitrary vector, and this is now part E, here it starts. A times x equal to B is consistent, means at least one solution for every B, for every B vector. I just leave it like this. And part F is actually even stronger than E. A times x equal to B. Here we have consistent means has at least one solution. Part F says now it has exactly one solution. And now you can say, oh, but wasn't this exactly what we did before? Here in 1.62, and that's correct. That's actually why the book has 1.62 first. Also, this is exactly what we need now to show this. So it turns out showing this is not so much work anymore. Only one step actually requires a little bit of thinking. So we show this. So first we remember theorem 1.53. 1.53 was just the parts A to D. So 1.53 essentially tells us that A implies B, implies C, implies D, implies A. So that was 1.53. And now we make actually detour from here. We say A implies F, implies E, implies A. We only need to come back from E to any of these because they're equivalent, but we just make here another circle. Okay, so, and it turns out, like I said, A implies F was just our theorem 1.62. So there's nothing to do anymore. A implies F by theorem 1.62. F implies E. If it has exactly one solution, for sure it has at least one solution. So F is actually stronger than E. So for sure F implies E. Because F is stronger statement. Okay, so the last thing is that what's left is now, if it's consistent for every B, why does it have an inverse? So that's what we still need to show. And I just like to do this here. So now we need to show E implies A. We need to be able to go back to the statement that A has actually an inverse matrix. But we know E says AX equal to B can be solved for every B. So by E, we can solve A times xj equal to ej. Remember, ej was column J of the identity matrix. So we can solve ax1 equal to e1, ax2 equal to e2, and we can solve them because you can solve ax equal to b for every b, and these are now our b's. So then define a matrix, capital X. You make these vectors just the columns. So column 1, column 2, up to column n. Then A X is equal to A times column 1, column 2, up to column n. Now we learned we can distribute the matrix multiplication into the columns to the right. So we have AX1, AX2, up to AXN. But now what is XN? Oh, AXJ is EJ. That's how we actually came up with these X vectors. So it turns out this is column 1 of the identity, this is column 2 of the identity, and this is column n of the identity. So this is column 1 of the identity, column 2. If every column is the column of the identity, this is the identity. So that means there is a matrix X such that AX is equal to I. And now we just look at the last statement, our last theorem 1.63. If there's a matrix B such that AB is I, our B is now the matrix X, then X is actually the inverse of A, so A is invertible. So by theorem 1.63, X is equal to A inverse, so A invertible. So this is now really nice. So if you have an invertible matrix, that means AX equal to B, for every B has exactly one solution, and it's always A inverse of B. So this theorem really essentially finishes for us at least, the theory of square linear equation systems. So you need to take the coefficient matrix, figure out, is this invertible? If it's invertible, it has only one solution. If it's not invertible, we know also it's either not solvable, or if it's solvable, it has many solutions. So in some sense, this finishes kind of the theory of square linear equation systems. And like I said, I have one little result left, but I don't like to push it through now. And also this little result, actually you don't need for the homework, but I think because I also assigned some written homework today. So the homework which I do today is I only assign the online homework for section 1.5. And later on in the afternoon, I post some questions from the sections we covered this week until today. And this is written homework, which is sent to you by, I think, Monday midnight. I will send you an email with a list of questions, which you have to do then on paper. Then you scan your paper with whatever app you have on your phone and submit the PDF by Monday midnight. So because once a week, I like to give some written homework, which I really create by hand. And it will not be too many questions, at most 10. I think this week, maybe even less, maybe 8 questions, which I like to see how you solve them in a written form. And as I said, I have not made this up, but so later on you will get an email with a list of written homework questions, and I will also post them on Cougar courses. Okay, so then I would say that's it for today. Any questions about the last thing, what we did, or anything else from today? Are we okay?
I'm good, thank you.
Okay, so later on, I think I put it at 10:15 or 10:30, you will see online questions for section 1.5. 1.6 online question I will assign on Monday, but there will be later a list of questions for homework, which you should do by hand, write it on paper and scan it. And that will be due Monday night then. No? Okay, then thank you very much. And I see you either on Monday or later on at 3 o'clock in the office hours.
Thank you.